This program demonstrates the floating point data types, which are float and double in C++. This program will be using pi, which is written here into the comments. All right, let's start by creating a float, which is the smaller of the two data types between a float and a double. So a float pi, and I'm just going to go ahead and in fact I'll just copy this entire line instead of retyping. So float pi equals here 3.141592. Yep, that looks about right. And let's output pi. And then after I will add a new line. Okay, let's compile and run the program. We can see it's been truncated. We only have the first 5 of the decimal points for the pi value. And this is because cout has actually truncated that output of pi. So what we can do is we can set precision, and we'll set this to a large number. Let's just say 100. So what we're telling cout that we allow the next variable, which is pi, to be as precise as it can be. We're just at least up to 100 decimal points of precision, which is far more than the number of decimal points we're actually providing. So we're effectively saying just be as long as you are. In order to use set precision, we need to add in one include, which is IO manip, which means the input-output manipulation. And that's what this function is doing, is manipulating the way the output works. So let's save, compile, run the program, and we can see that the floating point value retains most of the precision. It's not exact. It's actually done quite a good job. 3.14159, that's the same as over here. And then it seems to change a little. It's got, the next is 265, but on the other one it's 274. So we're starting to lose precision, and that's due to the precision level of a float. Now if we were to change this data type to a double, save, compile, and execute, we can see this more precision has been retained. So we have the same 3.159, so that's the same, and then it's got 26535. Let's do that, 26535, which is the same here, 26535, and then it has 8979, 8979. So the precision has gone much further out, and then, oh, here we go, here's where it changes. Then it goes 32115. This one just goes 323. It's different. So the double precision works just fine up to about here of pi. So we're getting 3, 6, 9, 12, 15 decimal points of precision using a double, whereas when we used a float, we were only getting 6 points of precision.